Hi, Assalamualaikum. So our topic today is about Simpson's 1/3 rule. Okay, basically it involves the process of integration. So this integration can be represented by a symbol of a stylish S or a symbol like worm. Okay, this symbol. Okay, and then this means summation. Okay, before we go further, so what is the application of this Simpson's rule? So basically, it can be used to find area or volume. Okay, specifically in civil engineering, the example is like, okay, to estimate a cross section of a river. And then the second is can be used to estimate cut and fill for road construction. Okay, for example, let's say you have existing level, and then this level is the proposed road elevation. Okay, how to get this proposed road elevation? You need you need to cut this section and then fill up into this section. Okay, and then to get the area for this cut and fill section, you can use this Simpson's 1/3 rule. Okay, and then we go to the basic formula. Okay, for Simpson 1/3 rule. Okay, as you can see here, this is the basic formula for one segment. Okay, for one segment for Simpson rule. Okay, as you can see, for example, the area, okay, because the application of Simpson rule is to determine the area. Okay, so the basic formula for one area is refer to the integration process from point x0 to point x2. Okay, and then with the function, okay, the function is referred to this curve. So equivalent to h over 3, okay, h over 3, h is referred to interval, okay, to the interval from the first point to second point, okay, from this point to this point. So this is referred to h. Okay, and then the first function plus for second function f1 plus f2. Okay, meaning that the function at x0, so f1 is in the middle, so f2 is referred to the last point. Okay, this is the basic formula for one segment by using Simpson's 1/3 rule. Okay, how to get this formula? Basically, it's refer. Okay, we can refer to this figure. Okay, basically for the basic formula, it's require. Okay, they require two segment. Okay, meaning that with n equal to 2. So how to get these two segment? So you need to use 3 point. Okay, the 3 point. So x0, x1 and x2. And then from this 3 point, you will get 2 segment. Okay, this is one segment, and then this is referred to the second segment. So then, okay, as I said to you before, so for the first area, okay, because this is for basic formula, okay, for the basic formula is referred to for the first one area, so it involves integration from x0 to x2, okay, with the certain function. Okay, basically for Simpson rule, as you can see, the function is always represent as up of the parabola. Okay, the function is always represent as parabola. So the formula is represented by the polynomial equation. Then you just plug in the formula of polynomial, okay, for fx. So you will get for a1 for the first area, so you need to integrate from x0 to x1 with the function polynomial function ax power of 2 plus bx plus c. So integrate to x, okay, and then this formula, okay, this one I want to show you how to get the derivation of the basic formula. Okay, basically before this you need to integrate from x1 to x0. Okay, you need to integrate okay, from x1 to x0 with a certain function of x. So in this example, as a reference, so the reference, so you can use the integral from h to negative h. Then the reference point of 0 is referred to the middle point. Okay, so this is the easiest way, okay, to derive of this formula. We need to set as a reference. So as a reference, so you just use like this. Okay, so the middle interval, so you can set as a at the function fx at point as a 0, and then for the next point is you can use as a h, okay, because this is the interval h, and then behind the 0 is the negative x, okay, the negative x. So then the integration, and then the integration happen from negative h, from h to negative h. Then you will get as, okay, lastly for the process of the integration, so you can refer to my notes because I have put all the integration process here. So finally you will get as this formula. Okay, this is the general form by using integration from x to negative h, from h to negative h. And then, so if we look in detail, basically, for example, for each point, okay, before this we just use general method. Okay, if we look in detail, okay, for each function, okay, for example, we start from here. Okay, for x, for the first point, x equal to negative h. Okay, before this, so the function can be represented by, okay, the polynomial equation. Okay, the polynomial equation. So you just replace the x. Okay, you just replace the x as negative h. So then you will get at the point, okay, at the point x equal to negative h, the function here is referred to ax power of 2 minus bh plus c. Okay, and then for the second point, okay, x equal to 0 at here, so you will get the polynomial equation or the function equation as c. Okay, you just replace x with 0, so and then finally you get c. Okay, and then for the last point, because the basic to derive the basic formula you need 3 points, so the third point is referred to x equal to h. So you just plug in into the polynomial equation, so finally you will get ah power of 2 plus bh and plus c. Okay, So then when simplified, the formula you will get like this. Okay, polynomial negative h, polynomial at 0, and polynomial at h. Okay, and then from this integration, okay, because the integration involved from h and negative h, so because for h and negative h is quite similar, so you just add, okay, you just do the summation, so you will get as, so you will get 2ah power of 2 plus 2c, okay, because this is for negative h and h. Then you compare this detailed formula with the general formula, okay, the general equation. So when you compare, you will get like this, okay, because for, okay, you will get like this, okay, for general equation. So because you get the general equation as, okay, this is the general equation. Meanwhile, this is, okay, and then because you want to compare for both form, because this form in ah power of 2, so that's why you can simplify, okay, you can expand this formula, okay, you can simplify into 2ah power of 2 plus 6c. So then you just take out the coefficient h over 3, and then you can get 2ah power of 2 plus 6c, okay, because when you simplify, you can get 2ch. Okay, and then because the final, okay, the simplification from the general equation you get 6c, but from this detailed equation you got 2c, so meaning that the rest will be 4c. Okay, as you can see here, for 2ah power of 2 plus 2c is come from the p negative h and polynomial h. So for 4c is basically referred to for polynomial at 0. So because the polynomial at 0 is c, so you just put 4c, okay, the coefficient is 4. And then finally, when you rearrange, you will get, okay, h power of h over 3 times function, the first function, okay, because this one is referred to the previous formula, so it's referred to the first point at, also the function at the first point, okay, because p naught is referred into the middle, so this is 1 for f1 in the middle, okay, and then the last one is the last point, so at ph, okay, this one is the first point, this is the first, this is the middle, and then this is the last point. So this is the way how you get the derivation of the formula. However, in most cases, the segments are normally more than 2 number. Okay, it's not only one segment. Basically, for a whole area, it will involve more segments. Okay, so that's why to get the area, so you need to use, okay, it will involve a few area. For example, okay, in this example, it involve the first area, okay, it will involve the first area, okay, second area and third area. Okay, how to know the how many area you will get? Okay, you must remember, okay, first area is referred to, okay, first area, because first area is referred to segment, to n. So in this case, you have 1, 2, 3. So in this case, you have 1, 2, 3, 4, 5, 6. So meaning that you have 3 area. Okay, because one area is referred to 2 segment. So right now you have 6 segment. So is refer to 3 area. And then you just plug in, because in the previous slide, one area is represented by the formula h over 3, okay, by the formula h over 3 time function f0 plus 4f1 plus f2. So you just represent, okay, this formula, but you need to be careful with the interval. Okay, as you can see, at first area it involved from point x0 to x2. Okay, meanwhile for area 2 you involve from point x2 until x4, and then for the area 3 is involved from point x4 to x6. Okay, this area, okay, this one is the area number 1 from x0 to x2, and then for area number 2 is x2 from x4, and then for the area number 3 x4 to x6. And then okay, you can expand this formula, and then finally you rearrange by according to the function. Okay, for example, as you can see here, okay, finally you will get h over 3 f0, okay, and then for f1, and then you will get 2f2. Okay, how to get 2f2? Because in area number 1 you have 1f2, so for area number 2 you get 1 area f2. Okay, you get one function f2. So that's why you just sum up this function, you will get 2f2. And then for f3, and then it same goes to f4. Okay, how you get f2 f4? Because in area number 2 you have function number 4, and then in the area number 3 you also have function number 4. So because this is the same function, you just sum up this function, so you will get 2f4. So for f5 and finally f6. That's why, okay, finally the formula for multiple segment Simpson one-third rule is equal to h over 3 f0 plus 4f odd. Okay, as you can see, odd. So what is the number of odd? The function number 1, the function number 3, the function number 5, plus 2f even. Okay, as you can see, the function number 2, the function number 4 is 2. Okay, so plus fn. So this is the formula for multiple. Okay, I think that's all for Simpson rule. So basically there are two formula. Okay, the basic formula, and then the formula for multiple segment for Simpson rule. Okay, that's all. Thank you.